Hello, thank you for joining our webinar on how to build a customized server. My name is Edmund Lee. I'm a Managing Director at SyncusTech, and joining me today is Sue Lee, Marketing Manager at SyncusTech as well. We've built the webinar around a case study where we worked with a system integrator like you to develop a customized server for the system integrator's customer manufacturing plant. Before we begin, wanted to share a little bit about SyncusTech. We're what's called an original design manufacturer. We've had 25 years of experience in R&D and expertise around building custom motherboards, systems, and servers. We specialize in direct delivery of small to medium quantities. It's not high quantity, and we pride ourselves in doing this in shorter lead times and minimal development costs. What is a original design manufacturer? Why work with an original design manufacturer? Well, there's various reasons, but the biggest one and the obvious one is there's customization required to service your customers. There's a lot of options out there, but the standard products are an issue because if you use a off-the-shelf motherboard or a system, it could be soon discontinued or become obsolete very quickly, and now you have a system that you cannot support. You could try to design your own boards and systems and servers, but that requires experienced R&D teams in-house, and that costs a lot of money. And why would you want to build up that expertise when you're not really going to focus on build a business around that aspect of it? You can choose to work with big brand manufacturers. They all provide these products and support, but there's going to be extensive lead times, a lot of red tape, different layers of hierarchy, and they're not going to be as flexible as you need them to be, has been our experience. So working with SyncusTech, you get high quality original design manufacturer motherboards that meet your needs. We're comfortable with smaller niche opportunities, smaller quantities, medium-sized quantities, and I think the biggest and most important benefit of working with SyncusTech is you get longer-term guarantees around the system you build. And we found, and that's why we're offering this webinar to system integrators, is partnering with the right system integrator has been really beneficial for us. System integrators function as the translator between the customer needs and a hardware requirement. And working with system integrators, we were able to design superior products that are meeting the end customer's goals. The four key questions that you will get as a system integrator when you're trying to build a customized server is, what's the most cost-effective hardware? Is it going to be scalable if I build it? And what is the right hardware for the application that I'm trying to run? And how do I securely back up my data? So those are the key questions that will come up, and we really built our case study around these four questions. So without further ado, we'll get into the case study. Our experience with working with a system integrator and a manufacturing plant was the system integrator's customer, the end customer that they're using the servers. The webinar format is not really ideal to exchange ideas and ask questions and get those answered. So at the end, we'll share our contact information. We're happy to set up a separate meeting with you to discuss any of your specific questions. As I mentioned several times now, we worked with the system integrator. The system integrator's customer was a manufacturing plant. With the advent of Industry 4.0, a lot of automation going on the plant floor, IoT, there's just a lot of growth, rapid growth in the demand for servers on the factory floor. There's a ton of data being generated, and then the analysis of that data to bring out meaningful changes to the manufacturing environment is paramount to stay competitive. And the existing servers offered really was not optimal for the manufacturing plant due to several reasons. It's not really scalable. It's really cost prohibitive. Servers are quite costly these days. It wasn't easy to back up the data or create a secure backup. And there's because it's a manufacturing plant environment, the durability and the mobility was a huge concern. And again, to address these, there wasn't really any product available in the market that was available today. So the system integrator, faced with this problem, wanted to create an infrastructure as a service cloud platform for the manufacturing plant's manufacturing execution system, MES application. They wanted to use a OpenStack, FS, and a MongoDB environment. And as I mentioned, finding an off-the-shelf solution was simply impossible. So here's a little schematic of what the various applications that were being used. I won't go over each one, but there was, if you wanted to design what the client needed, basically you needed multiple machines working off of OpenStack, FS, and MongoDB on a really infrastructure as a service type of environment, interfacing with the various applications. So that's the situation. What approach we took to develop the customized server. It was a lot of back and forth, a lot of discussions, a lot of meetings around design requirements, feature requirements, performance requirements, all of that. But how we did it is we basically came up with a couple of design principles. Those design principles allowed us to guide us to create ultimately a very effective solution. It needs to be a compact system. That was the biggest requirement, if you will. And so we don't want a data center with a rack environment with multiple servers in there. That's just a lot of infrastructure, working with the building facilities. It was not feasible to get into that big capital investment. So we needed a compact system that would address the application needs. What we came up with was a server cluster that really looked like the right-hand side. So it had 5 CPU nodes, and so that would be your equivalent of a rack server that was put into this cluster. At the bottom of the 5 CPU nodes, we had a hub node for network configuration, and then at the bottom it had a power node to provide power to all of these various nodes. All of these were designed to be sliding for easy maintenance. The system needed to be flexible and expandable. So how we address that, you saw there were 5 nodes, so you can use 1 node, you can use 5 nodes, so it's expandable that way. Or you can add more of these clusters parallel, and so that's another way to be flexible and expandable. But we also utilized our expertise in custom motherboards. And so we were able to create 2 different motherboards for the customer and choose between the 2 different motherboards depending on the application needs. So one was based upon an Atom CPU and the other one was an Intel Haswell platform-based motherboard. We're actually working on a 3rd motherboard using Skylake that'll support 32 gigabytes. And then the motherboards utilize mini ITX or EPYC board architecture for some standardization. We needed a customized network configuration, customizable, I should say, network configuration for data management. So we came up with a switch hub and a hub node. The two switch hubs connected each of the nodes, and then the L2 switch hub was provided for compact design. The control hub node was ultimately connected to the factory software hub, so it was connected to the customer software. Another design principle, portable chassis. Again, the customer didn't want a data center, so we created a lightweight aluminum design, and it was all in one. There were wheels and handles provided for ease of moving around and mobility. We wanted it to be durable. Again, a plant environment, a ton of vibration, so we added anti-vibration pads to the hard drives to provide extra stability and durability. This is the ultimate spec sheet of the product we developed. I won't go over the details. We can send you this if you want. But this was the end design of the product. And as you can see, there were two motherboard options, and then the chassis and the node structure is what we built. So there were several benefits, impacts, or advantages that was achieved through this. So on each of these subsequent slides, you'll see kind of a current server environment versus the new server environment and what type of advantages or benefits we were able to achieve. In the current environment, you had various different needs, DB, application servers, storage server. So if you started to add up all these different servers that were required for each application, it was really expensive. We were able to provide a customized server that met the performance requirements in a single unit, a compact design, and we were able to save the customer 80% in cost. 80%. That's a substantial reduction in cost, and so it was a very cost-effective way to address the need. The scalability, cost-effective scalability was another benefit we achieved. Any of the servers, single servers, if you needed to get a higher performing server, then you needed to replace the server basically. And that meant shutting down the server, replicating all the data, and if you do that, you're causing an disruption to the business, which was not ideal. In the new environment, you just add a node or a server cluster to the system, and you don't have to shut it down. It's really expandable without an interruption. Fault tolerance is another area that we improved substantially. Again, if you use single servers for various applications and a particular server goes down due to a hardware failure, if the data is lost, the business is facing a disruption, it's not good. Under the new environment, we had replicas being made, connected through the cluster, and it's real-time replication. And even if one server in the cluster goes down, it doesn't really affect the overall environment or the platform, so you are able to continue to operate, and you're just going to switch out that faulty machine. Another big one, there's no data center requirements. So data centers, if you're going to create one, you want cooling, you need power, you need internet connection, all of that in a separate environment. So in a existing plant environment, where do you have space? Trying to find space to create that data center is a big hassle. Again, a lot of capital investment required to do that. We don't need to do that. It's all in one mobile chassis. So that was a huge benefit for the customer. Last advantage we have is that it's a high-performance concurrent processing environment. In the old design or the old environment, you had a single high-spec server, highest spec you can find. It had a file system, a web server, and a DB interfacing with all these different clients. Some clients asking for making a DB query, some clients making a web page request, and then some clients that doing some file downloads over FTP or what have you. So now in the new server cluster environment, you have multiple nodes, and each node is dedicated to an application. All of the clients interfacing to the cloud OS, and so it's very performance oriented, and it's very customizable depending on what type of demand each application is getting. So in summary, the strategic approach, the custom approach we took, working with the end customer and the system integrator, we were able to create a cost-effective, scalable, simple recovery and high-performing concurrent system that we call the IS solution. So infrastructure as a service solution is what we're able to achieve. Again, addressing questions through a webinar format is not that ideal. So we'll conclude the webinar today. Here's our contact information. Please reach out to us if you have any questions. We're happy to address them, and we look forward to interacting with you and working with you. Thank you very much.